Next lesson, lesson 7. It's lesson 74 on page 188, and it's 7.4, motion with variable acceleration. The difference here is this variable acceleration. This means we cannot use SUVAT. Okay, so that's the most important thing that we take from that bit there. Well, not the most important thing, but a very important thing. So we know that velocity is equal to the gradient of a displacement time graph. If the graph is not linear, that means not a straight line, the gradient changes. But at a particular point on the graph, we can say that the gradient of the displacement time graph is the velocity at that instant. Okay, so when we had the SUVAT equations on the previous page, we had straight lines basically. On the previous sessions, straight lines. Okay, whereas when we've got variable acceleration, they're not going to be necessarily straight lines. And it's a bit more like in real life, so you would things like this. So the gradient of a velocity, this velocity time graph, is the acceleration at that instant. So there, the gradient is the of a point, because it's got to be at a point now. So if we know s as a function of t, we can work out velocity by differentiation. The velocity is the rate of change of displacement. So velocity is ds by dt, or v is s dashed. Okay, velocity is the first derivative of displacement. Similarly, acceleration is the rate of change of velocity. So we obtain acceleration by differentiating velocity with respect to time, which is the same as differentiating the displacement twice with respect to time. Okay, so now because the graph is not linear, it's going to be a function of time, so we'll differentiate it. Right, key point. Yeah, this is what we just said. A is dv by dt, which is d2s by dt squared, or A is v dashed, which is s double dashed. Right, a particle, example 1. A particle moves in a straight line so that time t seconds, its displacement s in meters from an origin is given by s is t to the power 4 minus 32t. So this means that s is t to the 4 minus 32t. Right, so the velocity is ds by dt, rate of change of displacement with time, 4t cubed minus 32. And it says evaluate its velocity and acceleration when t equals 2. So v of 2, 4 times 2 cubed minus 32, which is 0. If it's 0 meters per second, it means it's at rest. Then the acceleration is dv by dt. So this is going to be 12t squared, and that's going to be 0. And the v of 2, this is 2, not t, v of 2, 12 times 2 squared, which is 12 fours, which is 48 meters. Sorry, that's not velocity, that's acceleration. Acceleration, because we differentiate velocity, meters per second squared. Okay, so it's picking up speed quite fast actually. There we are. We can also write the relationship between SV and A using integral, so that's going back the other way. So this one, this way we've started with S and we've differentiated downwards. If we start with A, and then we can integrate to get back to S again. Okay, so Oh, let's see what it says here. Look, velocity is ds dt, so this means that s, integrate both sides with respect to t, so it's the integral of v dt. Acceleration is dv dt, so v is the integral of a dt. Okay, so it's going backwards. If we start with s, and then we can do s dashed, which is v, and then we can do v dashed, which is a. If we start with a, we can do the integral of a dt is v, and then the integral of v dt is s. So one way we differentiate, or we go back and integrate. Okay, so particle starts with velocity 2 meters per second. That means we're in this here. Velocity 2 meters per second, and moves with acceleration a equals 6t plus 4 meters per second squared. Calculate its velocity after 5 seconds. Calculate the distance it travels at that time. So when t equals 0, that's the start. Velocity is equals to 2 meters per second. Acceleration is 6t plus 4 meters per second squared. Okay. Calculate its velocity. So if we've got acceleration and we want velocity, we can say velocity is the integral of acceleration dt. So it's the integral of 6t plus 4 dt. So this is the add 1 to the power divided by the new power. And then 4 becomes 4t and c. So this is going to be 3t squared plus 4t plus c. Now we do know that when t equals 0, v equals 2. So therefore 2 is equals to 0 plus 0 plus c. So hence we have v is 3t squared plus 4t plus 2. Okay. And then, so this is an initial condition which has given us what the c is. Basically, that's it. So it says a, velocity after 5 seconds. So velocity when t is 5, 3 times 5 squared plus 4 times 5 plus 2. So it's 3 times 25 plus 20 plus 2, 75, 95, 97 meters per second. These are fast moving particles. Okay, and then it moves in this time. So the distance is it moving in a straight line? Calculate the distance it travels in that time. Well, everything is positive, so it's always moving forwards. I'm just going to integrate it anyway. So S. So for part B, we need the distance it travels in that time. So S is the integral of v dt. So it's integral of 3t squared plus 4t plus 2 dt. Add 1 to the power, divide by the new power is going to cancel out that 3. And then add 1 to the power, divide by the new power is going to make that 4 into it 2. That's going to be 2t plus another constant there. We can say t equals 0, s equals 0. So therefore d is 0. So s is t cubed plus 2t squared plus 2t. And then what's it say? When t equals 5, s is equals to 5 cubed plus 2 times 5 squared plus 2 times 5. So it's 125 plus 50, 175 plus 10 185. Okay. Right, next one. Particle moves with acceleration a 2t minus 3 meters per second squared. It's initially at point 0 with velocity 2. So t equals 0, s is equals to 0, v is equals to 2. Show that its direction of travel changes twice and find the distance between the points where this occurs. Okay, so what we've got to do here, we can start by saying find the velocity. Velocity is the integral of acceleration, which is the integral of 2t minus 3 dt, which is t squared minus 3t plus c. We can say t equals 0, v equals 2, so therefore c is 2, and v is t squared minus 3t plus 2. Okay. Now this velocity is a quadratic, and this quadratic will factorise. So v is actually t minus 2, t minus 1. Okay, and now if we sketch that quadratic, what we'll have is it will come down and it will cut the x-axis at 1 and at 2. So it'll come down and up like so. Just make that a little bit tidier. That's 1 and that's 2. Okay, so if you think here, the velocity is positive until t is 1, and then it goes negative. So that's the v, that's the time. So it's negative then. Negative velocity means it's going backwards. Positive means it's going forwards. So it changes direction. At t is 1 and t is 2 seconds. Find the distance between the points where this occurs. Okay, so what we need to do is we've got to find S when t equals 1 and t equals 2. So let's go back to v is equals to this. S is the integral of v dt. So it's the integral of t squared minus 3t plus 2 dt, which is t, add 1 to the power, divide by the new power, plus a different constant from the c up there. And what we've got here, t equals 0, s equals 0, so therefore d is 0. So s is t cubed over 3. It's 3t squared over 2 plus 2t. Okay, t equals 1, s is equals to 1. All the powers of t are 1. So it's 1 over 3 minus 3 over 2 plus 2. So this is a third minus 1.5 plus 2. Well, minus 1.5 plus 2 is the same as plus a half. So it's a third plus a half, which is 2 6 plus 3 6, which is 5 6. Okay, and then when t is equals to 2, s is 2 cubed, which is 8 thirds, minus 3 times 2 squared, so it's 12 over 2, which is 6, plus 2 times 2, which is 4. So this is 8 thirds minus 2 overall. Now 8 thirds is 2 and 2 thirds, minus 2 is 2 thirds. I'll change that into sixths to be the same as the other one, 4 sixths, and these are meters. Okay, so the distance between the points is actually 5 6, take away 4 6, which is 1/6 metre. Okay, so that means 1/6 of the metre. It's when it's going in the opposite direction to what it is at the start. And there we go, that's the end of that one. That was a quick one.